Hello dear students, I hope you are completing your work in your classwork notebook. In the last class we discussed about substitution method of solving a pair of linear equations in two variables. So let's recapitulate that. In substitution method, to solve the pair of linear equations in two variables, we have substituted the value of one variable by expressing it in terms of the other variable. And that's why the method is known as substitution method. We followed few steps for that method. In that, step number 1 is find the value of one variable, say y, in terms of the other variable, that is x, from either equation, whichever is convenient. Step 2. Substitute this value of y in the other equation and reduce it to an equation in one variable, that is in terms of x, which can be solved. Sometimes you may get statements with no variable. If this statement is true, you can conclude that the pair of linear equations has infinitely many solutions. If the statement is false, then the pair of linear equations is inconsistent. Inconsistent means there is no solutions, lines are parallel. Step 3. Substitute the value of x obtained in step 2 in the equation used in step 1 to obtain the value of the other variable. So this is how we used substitution method to solve a pair of linear equation in two variables. Now we will start exercise 3.3, problem number 2. Solve 2x plus 3y is equal to 11 and 2x minus 4y is equal to minus 24, and hence find the value of m for which y is equal to mx plus 3. Now here we have two equations. One is 2x plus 3y is equal to 11 and second equation is 2x minus 4y is equal to minus 24. We will solve these two linear equations in two variables by substitution method, and then we will substitute the value of x and y in this third equation to get the value of m. So now let's start how to solve this sum. First equation is 2x plus 3y is equal to 11. Second equation is 2x minus 4y is equal to minus 24. Now from second equation, from this equation, we will get x is equal to minus 12 plus 2y. Now this value of x we will substitute in equation number 1. In this equation we will substitute this value of x and we will get 2 in bracket minus 12 plus 2y bracket closed plus 3y is equal to 11. Continue solving this equation, you will get value of y is equal to 5. Now this value of y we will substitute in equation number 1. We will get 2x plus 3 in bracket 5 is equal to 11. So 2x is equal to 11 minus 15. So we will get x is equal to minus 2. Therefore, the value of x is minus 2 and y is 5. Now this value of x and y, this value of x and y, we will substitute in the third equation y is equal to mx plus 3. Let's see that. 5 is equal to m, value of x is minus 2 and value of y is 5. So here 5. So 5 is equal to m in bracket minus 2 plus 3. Continue this. So 5 is equal to minus 2m plus 3. Minus 2m is equal to 2 and we will get m is equal to minus 1. So this is the value of m. So we used substitution method. We got the value of x and y, and after that we substituted that value of x and y in the third equation, and we got the value of m as -1. Problem number 3. Form a pair of linear equations for the following problems and find their solution by substitution method. First part, the difference between two numbers is 26 and one number is 3 times the other number. Find them. Now here two numbers are there and the difference between the numbers is 26. Also, one number is 3 times the other number. So, we will assume one number as x and the other number as y. As the difference is given, so it means one number is greater than the other number. So, let the larger number be x and the smaller number be y. So we will write first equation as x minus y is equal to 26. This is my first linear equation in two variables. Now according to the second condition, one number is 3 times the other number. So as x is greater than y, so x is equal to 3y. This is my second linear equation. Now I will substitute this value of x in first equation. So I will get 3y minus y is equal to 26. Solve this, you will get 2y is equal to 26 or y is equal to 13. Now this value of y we will substitute in equation 2. This is my equation 2. I will substitute this value of y in equation number 2. So I will get x is equal to 3 multiplied by 13, which is equal to 39. So I got value of x as 39 and value of y as 13 by substitution method. So my larger number is 39 and the smaller number is 13. So the two numbers are 39 and 13. Now part 2. The larger of two supplementary angles exceeds the smaller by 18 degrees. Find them. Here two angles are there and they are supplementary angles. Also one angle exceeds the other by 18 degrees. So let the smaller angle be x and the larger angle be y. As y is larger than x, we can write y is equal to x plus 18 degrees. So this is my first linear equation in two variables. Also, they both are supplementary angles. So x plus y is equal to 180 degrees. This is my second linear equation. Now we will solve these two linear equations and we will get the values of x and y. So substitute value of y from equation number 1 in equation number 2. You will get x plus 18 is equal to 180 degrees. So 2x is equal to 180 degrees minus 18 degrees or 2x is equal to 162 degrees. So you will get the value of x as 81 degrees. Now substitute this value of x in equation number 1. So you will get y is equal to x plus 18 degrees. Now x is 81 degrees. So 81 plus 18 degrees is equal to 99 degrees. So two angles are 81 degrees and 99 degrees. So we solved part 2 by substitution method. Now part 3. The coach of a cricket team buys 7 bat and 6 balls for rupees 3,800. Later she buys 3 bats and 5 balls for rupees 1,750. Find the cost of each bat and each ball. Here we want to find the value of the cost of one bat and the cost of one ball, and the conditions are given. When the coach is buying 7 bats and 6 balls, the cost is rupees 3,800, and the cost for 3 bats and 5 balls is rupees 1,750. Now let us assume the cost of one bat as rupees X and the cost of one ball as rupees Y. So X is the cost of one bat and Y is the cost of one ball. Now according to my first condition, 7 bats and 6 balls. So 7x plus 6y, and the cost is 3,800. So is equal to 3,800. So this is my first linear equation. Now from the second condition, 3 bats and 5 balls for rupees 1,750. So 3x plus 5y, because cost of one bat is rupees X, so cost of 3 bats, so 3x, and 5 balls, so 5y. Add this is equal to 1,750. So this is my second linear equation in two variables. Now from this first equation, I will write X as 3,800 minus 6y divided by 7. So this is my value of X which I got from equation 1. Now this value of X I will substitute in equation number 2. So let's see that. 3, here I substituted value of X plus 5y is equal to 1,750. Now solve this equation and you will get 17y is equal to 850. So y is equal to 50. So this is the value of y which you will get after solving this equation. Now let us substitute this value of y in equation number 2, in this equation. So you will get 3x plus 5 multiplied by 50, which is equal to 1,750. Again we will solve this equation and we will get the value of x as 500. So the cost of one bat is equal to rupees 500 and the cost of one ball is equal to rupees 50. This is how we solve this sum by substitution method. Now part 4. The taxi charges in a city consist of a fixed charge together with the charge for the distance covered. For a distance of 10 kilometers, the charge paid is rupees 105, and for a journey of 15 kilometers, the charge paid is rupees 155. What are the fixed charges and the charge per kilometer? How much does a person have to pay for traveling a distance of 25 kilometers? Now, in this sum, total fare consists of fixed charges and charge per kilometer. So we will take two variables here, one for fixed charges and the other for charge per kilometer. So let the fixed charges be rupees X and the charge per kilometer be rupees Y. Now in the problem, two conditions are there. The first condition is for 10 kilometers the charge paid is rupees 105 for 10 kilometers. So the first equation, first we will pay X for fixed charges and for 10 kilometers we will pay 10y. So the sum of X and 10y is equal to 105. So this is the first linear equation, x plus 10y is equal to 105. Now there is one more condition, and that condition is for 15 kilometers the charge paid is rupees 155. So again we will pay fixed charge, that is x, and charge for 15 kilometers, that is 15 into y, 15y. So total charge for 15 kilometers, x plus 15y, which is equal to 155. So in this manner we got linear equations in two variables. Now we will solve this pair of linear equation in two variables by substitution method. So from first equation we will write x is equal to 105 minus 10y. Now this value of x we will substitute in second equation. So we will get 105 minus 10y plus 15y is equal to 155. Now after solving this you will get y is equal to 10. The value of y is 10. Now we will substitute this value of y in first equation. So let's see that. We will get x plus 10 multiplied by 10. Why 10 multiplied by 10? Because the value of y is 10 and here we have 10y. So x plus 10 multiplied by 10 is equal to 105. So we got the value of x as 5. So value of x is 5 and value of y is 10. Now what is x for us? X is the fixed charges. So the fixed charges is equal to rupees 5 and y is the charge for 1 kilometer or charge per kilometer. So the charge per kilometer is equal to rupees 10. Now there is one more thing in the problem. We have to find the charge paid for 25 kilometers. So what we will do for that? We will add fixed charges and charge for 25 kilometers. So x plus 25y, which is 5 plus 25 into 10, which is equal to 5 plus 250, or it is 255. So the charge paid for 25 kilometers is equal to rupees 255. So this is how we completed the problem. Now part 5. A fraction becomes 9 upon 11 if 2 is added to both the numerator and the denominator. If 3 is added to both the numerator and the denominator, it becomes 5 upon 6. Find the fraction. Now in this sum, there is a fraction. So let numerator of that fraction be x and the denominator be y. If you are adding 2 to both numerator and the denominator, it will become 9 upon 11. So if I am adding 2 to the numerator and 2 to the denominator, my fraction becomes 9 upon 11. So from here I will get my first equation. Same manner, condition 2 is if 3 is added to both numerator and the denominator, it becomes 5 upon 6. So if I am adding 3 to the numerator and 3 to the denominator, my fraction will be 5 upon 6. From here I will get my second equation. So how we will get the equations? I will cross multiply and then my equation will be 11x minus 9y plus 4 is equal to 0. This is my first equation. Same manner, I will solve this x plus 3 upon y plus 3 is equal to 5 upon 6. Cross multiplication will be done and then the equation is 6x minus 5y plus 3 is equal to 0. Now we got two linear equations in two variables. Now we will solve them by substitution method. So from first equation, the value of x is 9y minus 4 upon 11, which I will substitute in equation number 2, this equation. So I will get 6 in bracket 9y minus 4 upon 11 minus 5y, which is equal to minus 3. Now let's solve this equation, and after solving it, you will get minus y is equal to minus 9 or y is equal to 9. So we got the value of y. Now this value of y we will substitute in equation number 3. Here we will substitute. So let's see that. So x is equal to 9 multiplied by 9. We substituted y here, minus 4 upon 11. So we got the value of x as 7. Therefore, the fraction is x is 7 and y is 9. So fraction is 7 upon 9. So this is how we completed this sum. Now part 6. 5 years hence, the age of Jacob will be 3 times that of his son. 5 years ago, Jacob's age was 7 times that of his son. What are their present ages? Now here we have to find present age of Jacob and present age of his son. So we will take first one as x and the second value as y. So let the present age of Jacob be x years and the present age of Jacob's son be y years. Now in the problem, two conditions are there from which we will get two linear equations in two variables. So first condition is 5 years hence, means 5 years from now, age of Jacob will be 3 times that of his son. So present age of Jacob is x years. If I want age of Jacob after 5 years, I will add 5 to that. So age of Jacob 5 years from now, it will be x plus 5 years. And in the same manner, age of son, Jacob's son, after 5 years, it will be y plus 5 years. Now what is the condition? 5 years from now, the age of Jacob will be 3 times that of his son. So we will multiply son's age by 3. So what is the equation? X plus 5 is equal to 3 times of y plus 5. Now let us simplify this. We will get x minus 3y minus 10 is equal to 0, which is my first linear equation in two variables. Now there is one more condition, and the condition is 5 years ago. We are going in the past. So when we are going in the past, we will subtract that from the age. So we will subtract 5 here. Jacob's age was 7 times that of his son. So if present age of Jacob is x years, then 5 years ago means x minus 5 was the age of Jacob, and present age of his son is y years. So 5 years ago his age was y minus 5 years. Now according to this condition, Jacob's age was 7 times that of his son. So the equation is x minus 5 is equal to 7 times y minus 5. Let us simplify this. You will get x minus 7y plus 30 is equal to 0, which is the second linear equation in two variables. So in this manner, we got a pair of linear equations in two variables for the given condition. Now let us solve. From first equation, we will get x is equal to 10 plus 3y. Now let us substitute this value of x in second equation. So we will get 10 plus 3y minus 7y plus 30 is equal to 0. Continue. You will get y is equal to 10 years. So we got the value of y. Y is the age of his son. So the age of his son is 10 years. Now we will substitute this value of y in equation number 3 in this equation. So we will get x is equal to 10 plus 3 multiplied by 10. So x is equal to 40 years. Now what is x for us? Jacob's age. So the present age of Jacob is equal to 40 years and the present age of Jacob's son is equal to 10 years. So students, in this manner we completed exercise 3.3. I request you to complete this exercise in your classwork notebooks. Thank you all.